apparently it was hard to hear some of the people who weren't using microphones, so if everyone could just pass the microphone around when they speak in the next presentation, so that would be lovely. And this is our presentation about water testing in the Willamette River. I'm going to hand it off.
All right, hi everybody. So thank you everybody for coming out. We are glad you're here, and we are glad to be here too. So my name is Naomi.
My name is Molly.
I'm Hana.
I'm Eve. I'm Ariel.
I'm Rain.
I'm Layla.
I'm Andy. I'm Nathan.
I'm Viv.
And like it was previously stated, our experiment is on water quality testing. So we kind of came to this conclusion. We decided that we wanted to test the Willamette River actually for different basic water quality tests. And we decided we wanted to do this for a variety of reasons. The first of which is because pollution has been such a big problem, not only in the Willamette River, but just kind of in general in Portland. The testing or water quality affects not only the river ecosystems, but it also affects the community experience at the river and our future generations. And we realized that for us doing these tests would also provide a comparative basis for future groups.
So now I will be talking about just the Willamette River quality in general. So the Willamette River stretches 187 miles and is a major tributary of the Columbia River. The river has been subjected to change over many years. Today, dams control a majority of the river and it has been channelized. Now there are many man-made factors that contribute to the quality of the river, and usually it's in detrimental ways. The DEQ, or Oregon's Department of Environmental Quality, is the chief regulatory agency responsible for protecting the state's resources. The DEQ gives rivers a 1 to 100 scale score based on how healthy the water quality is. So the Willamette River's water quality is rated excellent near the source, though it gradually decreases as you near the mouth of the river. Between 1998 and 2007, scores have ranged from 81 to 93, which covers the categories of fair, good, and excellent.
So we did a lot of the basic tests on both the river and the pond nearby to the river. So we started with pH, which tests for the acidity of the water. We did dissolved oxygen, which tests for the amount of oxygen in the water. We looked at the temperature, which can affect the dissolved oxygen in the water. We looked at the turbidity, which shows the suspended particles in the water, and the conductivity, which tells about the conductivity of the water. And in the future, we're going to start testing for prescription drugs.
Alright, so for our procedure, we used a testing probe which helped us figure out the pH, the temperature, and the conductivity of the water.
This testing probe had a probe at the end with 3 sensors that tested for each of the 3 things it gave us the data for. We put this in the water, making sure it didn't touch the bottom, and the probe was on a cord to a meter, and it relayed all of the data back to us. Another test we did was the Winkler test, which tests for dissolved oxygen. To do this, we collected a water sample in a way that allowed us to not put oxygen from the air into the water sample. After that, we added a chemical which turned it orange and bound the oxygen to the water. This created a precipitate. The next chemical we put in dissolved the precipitate and also turned our water sample blue. For that, we titrated it until the blue sample turned clear. And then when we're done with that, the amount of titration we did corresponded to a scale of how much dissolved oxygen was in the water.
We also tested for turbidity, where we collected a water sample in a water bottle, and then we put it into a smaller bottle, and we put it in a turbidimeter, which sent a laser through so that we could see all the suspended particles, and then we compared it to other turbidity tests.
So there were 2 different locations we tested at. One of them was at a dock where we tested directly at the Willamette River, and the next place was a pond where the river degrees Celsius. The pH is 6.27 standard units. Dissolved oxygen is 7.03 milligrams per liter. Conductivity is 58 microsiemens per centimeter, and turbidity is 70.3 NTU.
And then in the pond, we came up with a temperature of 10.29 degrees Celsius, a pH of 6.49. For dissolved oxygen levels, we got 14.69 milligrams per liter. And for conductivity, we came up with 194 microsiemens per centimeter. And for turbidity, we came up with 5.31 NTU.
So here's a side-by-side comparison chart of the normal water levels and our results. So for temperature, which really affects the nature and the animals that's living within a river, was actually at a very good healthy level. Same with our pH, and pH is looking for hydrogen or hydroxide ions. So if the pH had a big dramatic change, that would indicate there was a lot of chemicals within the river. So our pH was actually very stable compared to the normal results. And for our dissolved oxygen, our pond results was well below the normal level, and our river was really high, which could have been affected by the currents of that day or the rain that was or the weather. Also for conductivity, both results was very stable, and for turbidity, our river was good, but our pond might have had some factors. Our pond's result had to do with our human errors where we could have accidentally stirred the water up. And some of the other factors that could have affected our results were the runoff at the sites, also the community and the boathouses around the rivers. Also, there's bridge construction going around the river, which could have affected the river. And some of the limitations we had was human errors and and limited trials. So yeah, we had very limited trials, and we only did 2 locations. So we didn't get as many results as we would like to.
So in the future, we're planning on doing further testing. We're going to test prescription drugs in the water. Prescription drugs can affect not only the river ecosystems, but can affect the fish that live there and such. So these are more complicated and expensive tests, so they require further planning and funding. We will send water samples to labs to get tested for various prescription drugs, such as ibuprofen and etc.
We will also be presenting these in classrooms because the best way to let people know about it is to get students aware of the fact that the water is polluted. Because as we all know, a lot of students like to go to the Willamette River during the summertime, but they are unaware of the fact that they're actually jumping in a water source that is full of pollution that can cause harm to them and animals around them. And
So, if you want to learn more about water quality and if you want to take action to clean the rivers in Portland or just anywhere in general, you can contact the Willamette Waterkeeper. They help maintain and inspect the water quality in the Willamette River, and the Columbia Waterkeepers, where they also do that as well, and they actually helped us gather data for our experiment.
All right, thank you so much. Do we have any questions from the audience? Yeah.
Have you guys done any work with SWIRP through PSU? Because I mean, this is kind of correlating to that as well. So I don't know if you guys looked into that. This is really a great project, I guess.
I'm not sure I don't think we have looked into that, but that's definitely sounds like something we might want to look into later on.
Especially if you're looking for further resources.
Alright. Anything else? Yeah?
I recall you guys mentioning about, testing the pond and the river for dissolved oxygen, but could you tell me how that would affect pollution of the water and what it shows if you read level of dissolved oxygen?
So dissolved oxygen, it's basically, it's just like more of a basic water quality test. It has to do with more of ecosystems up there, not necessarily pollution. Did you want to expand on that?
Yeah, well, so the pond that, wait, let's see our data. Yeah, it can be easier if this Aha, okay. So at our river, there's a lot higher dissolved oxygen because of currents and like the plant life that was there. And in the pond, there's a lot more plant life, so it's an essential part to the animals and the ecosystem around there. And that could be a big part of the pollution too, because plant lives help keep the ferroxin stable. So there's not as many runoffs or any other pollution that could be in. Also, plant lives helps take the pollution out of the water, which could also help the river clean itself up. And there's not enough dissolved oxygen or too much. It could affect the ecosystem to not be stable and cause the plants to die or the animals that's clean the river to die. So.
Anything else? Anybody? All right, well, it looks like we don't have any more questions, so thank you for listening to our presentation. We're looking forward to hearing the rest of them.
Yep, thank you.